Good morning, everyone. In this talk, I'm going to be introducing you to a few of the features of reflexive monism, which is arguably an inclusive paradigm for the study of consciousness. Paradigm, of course, does need to specify many things, and within the area of consciousness studies, to begin with, one would need an accurate account of the phenomenology of consciousness, both ordinary consciousness and potentially extraordinary forms of consciousness as well. One would have to specify an appropriate epistemology that could be used in the actual study of conscious phenomena. Then, of course, one has to develop appropriate methods for the study of consciousness, and in particular an understanding of how to relate first-person methods in consciousness studies to third-person methods. And that, of course, has been the subject of much of this conference. And then finally, one would hope to develop a global ontology, a system of understanding of consciousness within the context of the other things that we want to understand in the world, how consciousness relates to brains, how it relates to external physical reality, and so on. In doing that, I will be drawing on just a few elements of my main book, Understanding Consciousness, which was published in its second edition in 2009. But I've only got 30 minutes, and so I'll only be focusing on just a few issues which are central to the phenomenology of consciousness and also an appropriate epistemology for studying it. And you can also find many of my publications online on ResearchGate and Academia Edu. Here I'm just mentioning a few introductory ones, which relate firstly to the phenomenology of consciousness, particularly in the way that we're going to develop it in this talk, and then three subsequent publications relating to the development of an epistemology appropriate to the study of consciousness. And to begin with, we're going to deal with something that's very basic. How does subjectivity relate to objectivity in consciousness studies? And I'm going to suggest something very challenging, which is that many of the problems which surround an understanding of consciousness have to do with deeply rooted but false presuppositions that we tend to have about how we as observers, whether we're just subjects or acting as external observers, relate to the things that we observe. And secondly, how in general observations relate to what we think of as experiences. In beginning to think about these things, I think it's very useful to start off with one's own presuppositions about these basic things. So what I'm going to do is present a series of slides, some very simple statements. And for the purpose of this exercise, simply decide for each statement whether you intuitively think that the statement is true or false. So the first statement here is, physical objects as perceived are quite distinct from our percepts of those objects. Now, how about this one? The contents of consciousness are subjective. Perceived physical objects, by contrast, are objective. Is that true or is it false? Well, this one. The contents of consciousness are private. Perceived physical objects are public. Is that true or is it false? And here's a classical one that goes back to the time of Descartes. The contents of consciousness do not seem to have spatial location and extension. Or if they do, they may be loosely said to be located in the mind. The physical objects we perceive, by contrast, have a clear location and extension in the three-dimensional space surrounding our bodies. True or false? And then finally, the contents of consciousness are observer-dependent in that they exist only in the mind of the observer. perceived physical objects, by contrast, are observer independent in that they exist independently of the mind of the observer. True or false? Now, when you thought about all that, you might have thought some of the statements were true, some of the statements were false. Maybe you thought all of the statements were true. But whatever you decided, you'd probably agree that all of those statements are regarded as truths within common culture and within conventional science. And so it might surprise you that I'm going to claim that in an important sense, all of those statements are false. Now, the way to get into that is to consider a normal model that we have in our minds about the nature of ordinary visual perception. So in this diagram, we have three things. We have an object out there in the world, in this case, a cat. And we have light rays bouncing off the cat surfaces, innervating the visual system of the subject, and neural representations form on the subject's brain, and something else happens in the brain of an interesting but not fully understood kind, which is to provide the conditions for a conscious experience of that cat. And then, as a result of all that processing, a conscious experience or a percept of the cat appears in the mind of the subject. And typically what we think is that this cat is out here in the world that we can see is objective and public, whereas everything that takes place in our experiences of the cat is private and subjective. Now, it should be obvious that that first model is dualist in some of its presuppositions. So it has an object out there in space, which is one kind of thing, and then in the diagram, it results in a percept of that object, another kind of thing, and that precisely follows, for instance, Descartes' distinction that objects in the world can be thought of as res extensa, literally stuff that extends out in space, whereas anything that occurs in the mind can be thought of as res cogitans, or stuff that thinks or is thought like, in contrast to objects, for example. And it's obvious too that it's not easy for conventional science to deal with stuff that thinks if it's in no way part of the extended and measurable, quantifiable world. So the typical path followed both within science and within philosophy of mind, certainly in the 20th century, was to try and establish somehow or other that a percept in the mind is really nothing more than a state of or function of the brain. But note too that while dualists and reductionists disagree about the ontology of conscious experiences, in other words, about what they really are, they actually largely agree about how these phenomena appear, that is, about their phenomenology. And they also agree that physical phenomena in the world are completely distinct from our conscious percepts of those phenomena. And that underpins, if you like, the common view that physical phenomena out there in the world are public and objective, while conscious experiences of those phenomena, whether dualist, thought of in a dualist way or reduced to a state of the brain, are private and subjective. Now, there's something very odd about these shared presuppositions, and a question we can ask is whether there really are two cats. A cat is perceived out there in the world, and a percept of the cat in the mind. And the easy way to test for this is to simply attend to one's own experience as one observes something out there in the world. So, let's suppose you're actually looking at me on this screen, talking to you. Here I am, waving my hand about. And the question you have to ask is, as you're looking at me, do you have an additional experience of me anywhere in your mind that is separate from what you actually see out here in the world? And I would put it to you that if you do an internal examination of your visual experience, and I'm not talking about memories, images, thoughts, and so on, just your visual experience, you won't find an experience, a max experience, if you like, in your mind or in your brain that is separate, if you like, from the max that you see out here on the screen. And what follows from a very simple experiment is the conclusion that there actually is no separation between what we normally think of as a physical object, which is just the objects that we see around us, and those objects as experienced. Now, it's important to recognize, in recognizing that when we talk about a physical object, we use the term physical in two quite different ways. So, to begin with, we can talk about the world as described by physics, for example, in terms of quantum mechanics, and that's very different to the world as experienced. So if you're looking at this screen, for example, you see a screen as experienced and not a screen as described in quantum mechanics. Whereas the world as experienced, which is what we normally refer to as the phenomenal world, has properties which we know are partly dependent on the way that sensory and cognitive systems operate. So, for example, in vision, the colour, the lines, the angles, the movement, the perceived distance and location in space are all, in a sense, constructs of our visual systems. And it's easy to demonstrate that these are constructs of our visual systems. For example, within the study of disorders of perception, each of those properties can be a subject of a specific disorder of perception. So, for example, to take a simple example, without colour vision, you wouldn't see the world in a multicoloured way that you normally do. So, the phenomenal world, which is actually what we normally think of as the physical world around us, isn't the same as the world as physics describes it to be. And I should also say that within this way of looking at things, the phenomenal world has different components in it. So within the phenomenal world, we also have our bodies as experienced, and we experience our bodies as extended in space. So, for example, if you rub your fingers together and you feel a sensation at the fingertip, that sensation is also extended out in space, or phenomenal space at any rate, where the fingers seem to be, not in your mind or brain in some other Descartian res cogitans. So the question arises about how can one model that situation? And that's what led to my first publication on this subject, in which I developed what I called a reflexive model of how consciousness relates to the brain and physical world. And here we have it all represented in this simple diagram. And you'll see that much of this diagram is exactly the same as the ones that we've seen before. As before, we've got a cat as perceived out there in the world, for example, by an external observer to the whole situation. And light rays travel from the cat to the subject's visual system, where neural representations of the cat form just as before. And in turn, something else happens in the brain, which provides the conditions for a subject, S in this case, to have an experience of the cat. And in order to express the fact that what she sees is just a cat out there in the world, just as you just see when you're looking at my face, a max out there on the screen, something like that takes place. And so we set up what we might call a reflexive loop. An entity in the world exchanges information with a perceiver, who in turn experiences the entity out there in the world, roughly at close distances at any rate, where the object really is. But that does leave something interesting and mysterious, which is this bit. How does the perceived cat get to be out there if it is a construction of the mind-brain? Now, to begin with, we have to name the phenomenon. So in my own work, I call that perceptual projection. And we can also say something very obvious in general about it to begin with, which is that non-conscious processes within the brain produce these consciously experienced events, which may be subjectively located and extended in the phenomenal space beyond the brain. And we can also say that that's a subjective psychological effect. We're not claiming here that anything physical is being projected from the brain, although that was, in fact, a theory, an ancient Greek theory of Empedocles. And then you can study that phenomena in lots of different ways. And within psychology, there's a large literature, for example, dealing with the nature of space perception and how space perception also has disorders which can break down in many different ways. But for the moment, we don't need to go there. And I simply want to stress that in terms of phenomenology, the phenomenology of that, a cat is perceived and one's perception of the cat are one and the same. Now, if you need any persuasion that this subjective effect is real, it's very easy to demonstrate it in a way that you can actually observe it operating. Normally, perceptual projection happens so quickly and pre-consciously that one simply observes the effects. But in the case of this pattern that I've placed on the screen, it's so complex that the entire process is slowed down, and perceptual projection gradually forms if you do it the right way. So it's worth giving this a try. In order to observe this in action, bring your face right up to the screen. So you're within about, shall we say, about 5 inches from the screen. And then fixate your eyes beyond the screen so that it's simply a blur. And then keeping your focus behind the screen at a distance, slowly take your head away to about 30 centimeters away from the screen. And then what you should see is a concave pattern formed in depth on the screen, in front of which there is a double helix. One other interesting thing about this demonstration is that once you see it that way, you can actually scan different parts of the image as if you're scanning something in 3-dimensional space. The very same reflexive projective processes are involved in the creation of virtual realities. And here we have another demonstration using exactly the same diagram, but in this instance, as it applies to a virtual reality situation. So here, this is no longer a real cat out there in the world, but a virtual cat. And what the virtual reality system does is to project the images respectively to the left eye and the right eye of an observer, which would be projected to the subject's eyes if there were a real cat out there in the world. And not surprisingly, the brain receives exactly the same information that it normally receives, and the same processes, i.e. a neural representation of, in this case, a virtual cat, form in the brain the conditions for an experience of that obtain, and as a result, the individual experiences a cat, although it's no longer there, out there in space. So this is a kind of existence proof of the entire model. Virtual reality also provides a useful metaphor for the ontological status of the external three-dimensional phenomenal world. So one can think of the entire phenomenal world as a form of biologically evolved virtual reality that nevertheless represents something that's really there, usually quite well. Within philosophy, that would be regarded as a form of indirect or critical realism. It's not idealism, because there really, in this model, is a reality there to perceive. And that, in turn, takes you to the beginnings of reflexive monism. So in this particular vision, there's one universe, let's call it the thing itself, with relatively differentiated parts in the form of conscious beings like ourselves, each with a unique conscious view of the larger universe of which we are a part. And insofar as we are parts of the universe that in turn experience the larger universe, we participate in a reflexive process whereby the universe experiences itself. And now we're also in a position to say a little bit more about epistemology. And in particular, we can get back to this question of whether observed phenomena are public and objective, or whether they're really private and subjective. Now, I do not have direct access to your experiences, and you don't have direct access to mine. So I can't experience your pain, your thoughts, your color qualia, the way your body feels to you, and so on. Less well recognized is that the same applies to your observations of physical phenomena. For example, the way the sky looks to you, the way I look to you, and so on. And the same all applies to me. I only have access to my own observations of physical phenomena, and that includes my observations of physical properties if I'm doing science, for example, if I'm taking meter readings of the intensity and frequency of stimuli and so on. In other words, we each live in our own private phenomenal world, and the fact that that applies to science as well was noticed by the physicist Bruce Bridgman in 1936, who's the father of operationalism in physics, where he noted that all experienced observed phenomena are private and subjective, and in this special sense, science is just my private science. And here we can see how all this applies to a typical psychophysical experiment, where we have a subject looking at a light, and we treat the subject's experience of the light as private and subjective. And we have an external observer who thinks of the whole of his observations of what's going on, of the light stimulus and of the subject, as public and objective. But in truth, when he looks at the light, it has a phenomenology that's private and subjective to himself. And the same applies to his observations of what's going on in the subject's brain. So, whether one is a subject or whether one is an external observer, there is only private access to individual observed or experienced phenomena. However, there can be public access to the entities and events that serve as the stimuli for such phenomena. For example, the entities and events which the phenomena represents. And that applies, for example, to the entities and events studied by physics, as well as psychology. And we can then assume the following, that if the perceptual, cognitive, and other observing apparatus of different observers is similar, which we can assume given shared heredity, then we can assume that their experiences of a given stimulus are also similar. And in that special sense, experienced phenomena may be public in the sense that they're similar or shared private experiences. And that's how we get from subjectivity to intersubjectivity. So, to repeat, each private observation or experience is necessarily subjective in that it's always the observation or experience of a given observer, viewed and described from his or her individual perspective. But once that experience is shared with another observer, it can become intersubjective, and I've deliberately hyphenated that. In other words, through the sharing of a similar experience, subjective views and descriptions of that experience potentially can converge, enabling intersubjective agreement about what's been experienced. And to the extent that an experience or observation can be generally shared in this way by a community of observers, it can form part of the database of a communal science. Given all that, how does psychology differ from physics? Well, when doing physics, we're interested in the nature of the entity or event that the observed phenomena represents, and in how it relates to other independently existing entities and events, using the methodologies appropriate to physics. But when we're doing psychology, we're interested in the appearance of the observed phenomena as such, and in how the appearance depends not just on the entity or event as such, but also on the operation of our own perceptual and cognitive processing, in this case using the methods appropriate to phenomenology, for example, or psychophysics. In these instances, it is the questions one asks and the relationships that one investigates that distinguishes psychology from physics. The phenomenon itself may not change, and that was a point noted, for example, by the neutral monists, such as William James, Ernst Mach, and Bertrand Russell. We can give an illustration of all that with this simple visual illusion, which one can study from the perspective of either psychology or physics. So psychologists would be interested in the fact that this central line seems to slope down to the left. And if they were studying this illusion, they would ask subjects to take a straight edge and place it outside the figure and line that straight edge so it seems to be parallel to the central line, and in that way they would get the angle of the illusion. If you're a physicist, of course, you're interested in whether the line actually is sloping to the left, and so you'd get a straight edge similarly, but place it directly on the line, and that would establish, if you ignored the distorting cues, that the central line is actually horizontal. And that's completely repeatable, and any number of physicists would make the same observation, and any number of psychologists would do likewise, using their different measure operations. So in summary, whether the observed phenomenon is studied from the perspective of physics or psychology or psychophysics, the observed phenomena by either discipline would be public in the sense of private experiences they share, and repeatable. Only the measurement operations differ. So at this point, we can draw some conclusions. Can science be objective? Well, it can be objective in the sense of being intersubjective. But note that requires the presence of subjectivity, not its absence. It can also, of course, be objective in the sense of being dispassionate, accurate, truthful, and so on. And it is also important in science to have well-specified, repeatable procedures. So there is three senses of legitimate objectivity according to this analysis. But it can't be objective in the sense of making observations that don't in some way involve the experiences and cognitions of a conscious subject. So scientific observations and the knowledge derived from them cannot be objective in the sense of being observer-free. And that in turn allows one to specify in a very simple way what is of the essence in the empirical method, which, if the analysis we've given so far is correct, is if observers E1 to n, any number of observers, carry out specified procedures, P1 to n, under specific observation conditions, O1 to n, they should observe or experience result are. And the same applies to subjects doing first-person investigations. To put it more simply, if you carry out these procedures, you will observe or experience these results. And that's a principle that applies equally to psychology and physics. So, although the methodologies required to study conscious appearances are generally very different from used in physics to study the phenomena that those appearances represent, this reflexive, non-dualist epistemology unifies psychology and physics. And at that point, I have to leave it due to limitations of time. So thank you for your attention.